So, hello guys, and welcome to a new tutorial. So, I did a crystal tutorial a while ago, and yeah, let's update this a little bit. So, let's get started with a geometry node here, and let's make it round, and let's make it black, and let's call this GeoCrystal. And let's dive inside. So, first of all, we need a foundation, so let's get a circle here. Let's get it to the flat plane here, and let's get it to polygon, and let's raise the divisions a little bit up. So let's get a remesh. Let's get a remesh here, and let's remesh the circle here a little bit. So let's go on the division size a little bit smaller, so 0.05 should be fine, and let's get normals onto that. Let's get point normals, and we want to displace the point normals, so let's quickly use a mountain node. So of course you can use a custom noise, something like that, but for this quick demonstration here, let's get a simple mountain node. Let's get rid of the 0, 0, 0 offset, and now you can play a little bit with the height and element size and with the different noises, of course. So let's just reverse the normals here. Let's get an wrangle and just call it reverse, and of course there is a node, but let's do it quickly in wax. At n equals minus at n, and now we got reverse normals. So now we need to scatter onto the surface here, and let's get 15 crystals for now. And now we've got the normals here, and now we can scatter our crystal. But before that, let's just get a simple point here. Let's get one point here, and let's move that a little bit up, so the point is right about here. So there is the point. And let's just get a direction for the crystals. So let's get an attribute WAP here. Let's get the first input will be our points, and the second input will be our direction point. So let's import that. Let's import the point attribute. So import point attribute. Let's go to vector 3. It's the second input. So 1, 2, 3, 4. You can also see it down here. So 1, 2, 3, and 4. So it's the second input here for the point, and we want to import the position. So the point number will be point number 0, so we can just determine that with a constant and integer. And now we want to subtract the position here with our point, and what we will get is a direction to that point. So our normals on the scattered surface will be directed to the one point. Of course you can now introduce a little bit of noise, but that's fully up to you. So let's jump out of this, and let's create some pretty simple crystals for now. So let's get a box here. A box. Let's have a look. Okay, let's make the box a little bit smaller. Maybe something like that and something like that. So now we want some damage to the box or some cutting stuff. So let's get a really simple way of getting a pretty cool shape. Let's duplicate the box and let's set these values to the defaults. Let's get a copy to points, and let's just copy these boxes onto that box. So we will get something like this. And let's get an attribute randomize, and let's quickly randomize not the color, let's randomize the p-scale. So p-scale here, let's connect it, and you can see we've got a different scale on the copied boxes. So let's call the set p-scale, and let's get a ramp here, custom ramp. Let's get these a little bit up, let's change the seed here a little bit, and let's dial down the overall scale. So something like that. The next step will be a Boolean subtract. So we want to subtract these copied points from the box. So this is geometry A minus B. Let's switch that, and we will get something like this. So now let's get the size here bigger and here bigger, and let's get the uniform scale a little bit higher, and we will get something like this. So this is a really quick and dirty way to do this, but it's pretty efficient. Let's get a transform here, and let's get a copy to points. Let's get the points from our display surface here, and let's wire these in, and let's just rotate this here so it will go to the direction here. And of course you can play with this, so that's fully up to you. Let's duplicate the p-scale and let's copy it on here. And for now let's make the circle a little bit smaller. And let's make 20 crystals here. And let's get the p-scale on this value a little bit higher. So we will get something like this. For example, you can make them a little bit taller, and you can make here a loop to randomize each copy, for example. So that's fully up to you. So let's play a little bit here with the transform. Let's get the handle here, and yeah, now you can play. Maybe you will get something like this. That looks not bad. Or you can turn it like so. So that's fully up to you. So let's turn this a little bit here, and let's just leave it like that, but let's transform the whole thing 180 degrees around with the handle here, and we will get something like this. So the next step will be a loop. So let's get an for each connected piece loop. Let's connect the input, and we will get 20 crystals here. So for now I want to remesh each crystal, and I want to get the curvature. So let's get an VDB from polygons. Let's connect this, and let's have a look on one crystal, and let's dial that a little bit down. So 0.085. Let's convert this. So get a convert VDB node. So from assigned distance field or a distance VDB, we will convert this back to polygons, and we will get something like this here. So now let's recompute just the normals here to be sure, and let's measure the curvature. So let's get a measure node here, and let's get the curvature, and let's get the visualizer, tap on the handle here. Let's get this maybe to 1, And let's get here bake visualize range into output, so we will get an attribute for that. So now you can play here with your sliders, so maybe get something like this here. And now you can, so this is on the primitives, so when we go to our geometry spreadsheet, the curvature will be on the primitives. So we want that to be on the curvature, on the points. So let's get an attribute promote node, and let's promote the curvature from the primitives to the points, and let's select curvature. Will this ever go away here? No, let's just, yeah, okay. And now for just quick visualization, let's get a color here, color, and let's get ramp from attribute, let's get a curvature, and the ranges are, yeah, let's fit the ranges. So let's get a little asset here, and this will just fit the ranges between 0 and 1. And now you can see that's our range, and we can adjust that. So this asset here is pretty simple. I can show you it quickly. So it will get the geometry, and it will promote the minimum and the maximum into a detail attribute. So you will get the minimum of the curvature and the maximum from the curvature into the detail attribute, and that's a little bit of wax. It's nothing complicated here. So then I will import the detail and the detail max, and I will fit it between the values I want. So let's match current definition here, and now let's go further. So with the curvature, we can introduce a little bit of noise. Let's get a point warp. Let's get into the first input, and let's get our curvature attribute. So we want to use the bind node. So the bind node is therefore you can import attributes, and with the bind export you can export them. So let's get here the curvature. And let's just get it to color, and now you can see we've imported our curvature attribute. The cool thing is we can use that as a mask. So let's get a displace along normal here. Let's get a simple noise. Let's get a position. Let's get a position for the noise, and you will get something like this. And let's get here simple a multiply. So we will multiply the noise with the curvature, and you will get something like this. Of course that's way too much here, so let's get the scale down to maybe 0.1, something like that. And now you can play to get here a little bit of, yeah, a break up for the edges. So pretty simple, just use the curvature as a mask. For example, you can introduce into the curvature a little bit of noise and then overall noise to get some little bit more finer details. So now we want to get, let's get a normal. Let's get the normals here right. Of course here are intersections and so on, but we will deal with that later with a simple remesh. So let's get here a little bit lower, something like that. So Now I want some details inside a mesh, so let's get a VDB from Polygon. And now we don't want to use the surface, we want to use a density volume here, and let's get this up here, so 0.01. Let's get a volume visualization and just get the density field, and let's just raise the scale so we can see the resolution. So something like 0.005 is okay. Let's get a scatter here, and let's just scatter 3 points into our crystal. So now let's get a grid here, and let's make it a little bit smaller, and let's bump the grid up, so maybe 100 by 100. I think that should be fine. Let's get a simple mountain here, and let's displace here our grid. So let's get a little bit larger with that, and let's dial down the height a little bit, so something like that. Let's copy this to our points from the density volume, and we can use that as a Boolean shader to get details. So that's not what we want. We want some random rotation. Let's get the attribute randomize. Let's call this rotation. Let's call it randrot. Let's connect this, not the color. Let's get simple, normal, and let's get inside sphere. So we will get random rotation here. Pretty simple. Let's get the Boolean shader. So Boolean shader. Geometry A is not a solid, it's a surface. So let's get this to B, let's get it to surface, and now let's get these two here, and let's remesh our simple crystal here, and let's get this into that. And now for visualization you can use the exploded view here, and let's use let's use the connectivity here, class, and you can see we've shadowed our crystal here. So the next step is to remesh every single piece again. So let's get another loop here. This will be 5 pieces. Let's get here this again. And the cool thing is, with the simple remesh we will get these little intersections. So let's get it down to a good resolution, something like that. And in the end you can get a really simple smooth to smooth them a little bit out. So fill the quality 1, something like that. So now let's get here multi-thread when compiled, and let's get a compile block. So this whole block will run multi-threaded. So this is way more faster. Let's get this one here, and let's get this all the way down here. Let's connect this, and let's run it, and let's connect the output. And we are done. So this is, let's check the polygons. Okay, 4 million, that's alright. Let's color this in here, and for example you can get now, let's just only get 10 here. So without the compile block it's way slower, but with the compiled block it's pretty fast. So let's get this down here to 0.3. Let's cancel that, and let's get this up to 3 here to get it a little bit faster. So we will get something like this. Now let's get the connectivity node, because I want to tear them a little bit apart, and we can just do that with the explosive view here. So let's get a uniform scale from 0.01, and now you can see they are all a little bit teared apart. Maybe something like that. Cool. So this is a way to create crystals with, yeah, it's not the best way, but it's a pretty high geometrical way. So the cool thing is now you can introduce surface details with custom noises inside of WOPs or with wax. And for now, let's have a look. We want to get the curvature. We can get it in Redshift. So that's for the modeling part. Let's just throw down a material node here, and let's call this mat. So let's dive up and let's create a shop network. Let's create a ROP network, or yes, a ROP network. Let's just color this in. Let's call this Redshift as usual, and the out. Let's dive into the out. Let's get a Redshift custom here. Let's call this RS out 001. Then let's get a camera. Let's dive inside. Let's pick the lock here, because when you don't pick the lock, your camera, you can move all the way, but your camera will stay in the same way. So you will lock on the camera, and now you can move your actual camera. So let's find a cool position, something like that. So let's get here a higher resolution, and let's get another aspect ratio, something like 2.35. So we need a light, so let's get a simple light dome here. Let's color it yellow because it's a light. So RS light, let's call it light dome 001, and let's get here a simple shader here. Let's get the Pro Metal Studios, something like that, and let's build our shader. So we did the camera, good, we did the out, good, and let's get the shader here. So Redshift network, let's make this a little bit smaller, and let's call it RS Mat Crystal, and let's connect it here with the material node on the end of the crystal tree. So you can just hit Shift W and this little tree here will appear, or you can just get here. Let's just cancel it out here. You can just click on here and navigate to your material and click accept. So let's dive up, let's dive in, let's dive in. So we are now in the Redshift material. So let's get our rendering up here. Let's quickly start the render view. And we will see that. So let's get Rec 709 for now, and let's just disable the background, and let's get here depth of field. Let's just copy the focus distance here, and let's use a simple bokeh image. and let's hit the focus here, something like here. And that's pretty good for something like 90mm, like a macro lens. So let's move that quickly to the side, and let's move the camera a little bit back here. And now the image is of course fully out of focus. Let's refocus again here, and let's go a little bit down with the COC radius. So something like 0.25 should be fine. Of course you can play now with something like anamorphic lens, so the aspect and so on. So, but we want to create a cool material. So let's make this here a little bit smaller. First of all, I want to get, yes, something like a glass material. So something like a refractive material. So let's get a simple RS material here. And let's pipe that into the surface, and let's confirm that it works. It works. Good. Let's go to the glass preset, and you can already see it looks pretty cool right from the start, because we've got this intersections here. What you can do, you can get a loop inside of the fractured parts. So let me show you that quickly. You can get a loop inside of these parts here and refracture them again if you want to. So that will introduce a little bit of more detail. So let's just get here some quick marks here, and let's hit the render view here again. So this is our crystal for now. Looks pretty good, but we want a little bit more detail. So first of all, let's calculate the curvature. Let's get our RS curvature, let's get it to the surface, and with the curvature we will get a normal float value from 0 to 1, and we can calculate how convex or how concave the object is. So let's go down to something like 0.01, and let's get some more samples here. And of course, let's get a ramp, so we can refit that a little bit. Let's get a black out of here, and let's introduce some noise. So there's already a little bit of noise here, because the crystals are not perfectly flat here. But let's get some hacking here. So let's get a simple noise. Let's get it to a higher scale, so a higher frequency, something like 50 or 100, something like that. And for now, let's distort it a little bit, and let's introduce a little bit of distortion scale. And now let's use that ramp to ramp the noise again here. Not so hard, maybe something like that. And let's bring the whites a little bit closer together. And now we've got two different ramps from black to white, and let's composite these together. So let's get a composite here, and we want to get our noise and our curvature, and let's pipe that to the surface, and let's change it to multiply. And you can see we've now get the detail from the noise, from this noise we ramped. We now get the detail from the noise inside our curvature. And this is just to get a little bit more realistic breakup. For example, you can now change the offset and the seed, or get another noise. So this noise is pretty cool to get some roughness. So let's get our glass here, and let's get this to the roughness. And for example, you can see the outside is now pretty rough, and where the curvature is, it's pretty clear. So let's get a ramp here. Let's get a RS ramp, and let's just invert this whole thing. And now you can see it's pretty rough here, and it will get more clearly here. But that's just an example. Let's switch that again. And we've got our first detail. So let's introduce another material so we can blend two materials together. First of all, we need the blend. Let's get a noise here, just a simple noise, nothing complex, and let's ramp that again. And let's just ramp it like so. Let's introduce a little bit of noise here, 0.1 and 1.25. Or let's just leave it like that, and let's dial up the complex scale here, and just for now let's make it pretty big so we can see that good. And let's play here with the offset. So we will use that as a mask. So let's just get a null node here, and let's just call this out mask for the blender. So matte blender. Let's get a material blender. So this will be our, let's get them here. Let's get a glass material into the base color, and let's get this one here into the blend color, and we want another material. Let's just use for now, let's use like copper, aluminum. Let's use that, and let's start that up here a little bit and pump that out to the surface. And now you can see the cool thing is we now have got down here aluminum, or up here aluminum. So that's pretty nice to break that whole thing a little bit up. Let's just focus here, and let's get here a render area here. So that's pretty good for now, but let's get a little bit higher resolution here. Let's bump that up to 2 and to 2. So let's hit up the render view again, and now I want to introduce a little bit of bump mapping to get even a little bit more detail. So let's get a bump map here. Let's get a simple, for now let's get the max on noise, and I really like the, where is it, the Luca. That's pretty cool. Let's get a ramp here, and let's fit that a little bit to gray here, something like that. And let's get an actual bump map. Let's pipe that into the texture, and let's have a look on that. So bump here, let's get a RS material just to get the look. So that's of course way too much, so let's scale this down to 0.005. So we will get this little detail here. So that's pretty nice. Let's pump our builded material here in, and let's get that onto the aluminum shader here. And now you can see we've got here a little bit of bump detail. For example, you can use that with a slight offset, so it's not the same. Let's get here offset onto the glass material. So that looks pretty nice too when you do it with a glass material. Let's just get here an air as material. Let's pipe that in. Let's go here to glass, and let's pipe that into bump. So you will get these really cool details here, something like here, something like that, when you pump that into a glass material. So let's delete that again, and let's pump that, pipe that out to our main surface shader. And now, yeah, it takes time. So I let this render, and I will show you it in the end. So guys, that's the look for now, and I will show you in just a few seconds another example. So guys, welcome back. So I changed a few parameters and the material is just the same. I just got rid of the second layer, and this is now a glass material with some bump mapping and some roughness, and then you will get something like this here. So I hope you liked the tutorial, and I will see you in the next one.